Okay, we're going to look today at the Year 13 trigonometry, what are called addition formulae. Now, the good news is these ones we're looking at here are all in the formula book, but I'm going to show you where they come from and how to use them. The first one, the basic one, is known as sine of a sum. Sine of a plus b equals sine a cos b plus cos a sine b. It's not sine of a plus sine of b. We don't just times out as if it's an ordinary bracketed expression. And I'm going to look to actually do the proof of this, and then from this one generate all the other ones, the ones with minuses in, the ones with cos, the ones with tan in. So I've got a triangle here. I've got side p, side q, and I've split it into two right angle triangles with an angle of a there and an angle b there, and called m the height of the triangle. Now, with a little bit of rinky-dink basic trigonometry, I can say that, and I'll use it in some stage, so we'll write it down. Cos A equals adjacent over hypotenuse m divided by p. I can rewrite m equals p cos A. And from this triangle, cos B equals m over q, so I can rewrite m equals q cos B. I've got that the total area of the triangle, half AB sine C, is a half times p times q times sine of the total angle A plus b. What I want is to have the area written as these two sums, but with the p and the q in both areas, in both terms. So if I consider triangle 1 and its area, I can say it's a half pm sine A, and because I want that pq thing in there, the version of m that I can use is q cos b, so I can write that as half p q cos b sine A. Area 2, similarly, that's 2, sorry, is going to be a half m times q times sine b. And the version of m I'm going to use is the one with p in, p cos A. So I've got a half pq cos A sine b. And guess what? When I add these two together, I get the total area. So I get a half pq sine of A plus b. The total area equals number 1, half pq, and I'll rewrite the order of those two things. So we've got sine A cos b. And then similarly, this one, a half pq times cos A times sine b. Cancel out the halves, cancel out the p's and q's, and guess what? I've got sine of A plus b equals sine A cos b plus cos A sine b. So it comes from areas of triangles. And I'm going to use that to generate the other ones. So let's bear in mind, I'm going to, where b is in my original one, I'm going to replace with minus b. And let's recap that sine of minus b, because it's an odd function, equals minus sine b. And cos of minus b is no different. It's still the same as cos b. So I end up with sine of A plus minus b equals sine A cos minus b plus cos A times sine minus b. And what happens is cos of minus b is no different, so we get sine A cos b. And then, because sine of minus b is the negative of what it was before, that plus becomes a minus cos A sine b. And so sine of A minus b is sine cos minus cos sine. And you will often see the two of those written together as a plus or minus like that. So it's still sine A cos b, and then plus or minus cos A sine b. What it means is, if it's the plus, we take the top one, plus. If it's a minus, we take the bottom one, the minus. So that's two of our trig addition formulae. Let's now have a look at, without doing any different proof, cos of a sum, cos of A plus b. Now, you've got to remember in a right angle triangle, cos of one angle is sine of the other one, because what's adjacent here is opposite that one there, and the hypotenuse is always the hypotenuse. So sine of one is cos of another. So cos of A plus b equals sine of 90 minus A plus b. what I can do with this one is split this up as sine of 90 minus a, be careful with our plus minuses, and minus b. So I've now got sine of a difference. And I just said what that is. That's sine cos minus cos sine. So it's sine 90 minus a cos b minus cos 90 minus a sine b. And we know that sine 90 minus a is exactly the same as cos a. So I get cos a cos b minus, and then cos 90 minus a is the same as sine a sine b. And that's cos of a sum. So cos of a plus b is cos a cos b minus sine a sine b. And by the same sort of thing as before, when we've got b is minus b, so what would cos of a difference be? Doesn't affect the cos, so it's still cos a cos b, but it does affect the sign of this term here, so that will change to plus in the middle, sine a sine b. And that is cos of a difference. So we've got cos of a sum, cos of a difference. Notice the different plus minuses in the middle there. And the last one, and now when we look at tan of a sum, tan of a plus b is sine over cos, so it's sine of a plus b divided by cos of a plus b. I'm going to write it as a fraction, but with a bit of space, and you'll see why. So I'm going to write it as sine a cos b plus cos a sine b, space, divided by cos a cos b minus sine a sine b. And now what I can do, I can take every single term in that thing there, times or divide by the same thing, and it's still equal to what it was. So I'm actually going to divide every single term by cos a cos b. Stuff's going to cancel out in some cases, and when it's not, we're going to be able to write it in terms of tan. And then this one divided by cos a cos b, and that one divided by cos a cos b. So let's have a look at our four fractions I've generated now. The cos b cancels out there, so leaving with sine a over cos a, tan a. The cos a cancels out there, leaving with tan b. Everything cancels out for this first term to leave me with 1 for the minus. I've got nothing cancelling out there, but I can write it as tan a tan b. And this is tan of a sum. So tan of a plus b is this messy fraction, tan a plus tan b over 1 minus tan a tan b. And as before, if I change the b to minus, what effect does it have on the plus minuses? Well, it becomes, just change the signs, tan a minus tan b over 1 plus tan a tan b. And be aware that in the formula book they might write the two of them together, as I said before, plus or minus there, as tan a plus or minus tan b. So what it means is we follow the top one if it's plus, and we follow the bottom one if it's minus, and then minus or plus tan a tan b. So if I want tan of a difference, it'd be tan a minus tan b as above over 1 plus tan a tan b. That's what the plus minus mean in that case there. And that's my 6th edition formulae, all given in the formula book, but we're now going to look at how we use them.